Now let's look at a quick comparison between a single index model versus a multi-factor model in terms of the number of parameters to be estimated. We have seen that in case of a single index model, let's say the return of a security based on the return on the market, we have written it as alpha I plus beta I times the market return plus epsilon I. So what we are typically seeing is I need a return on the market, which is one parameter that I need to find out, and I need to estimate the different values of alpha I. So if there are n different securities, I need n different values for alpha, n different values for beta, and n different values of epsilon. So overall I require 3n plus 1 kind of data items in order to estimate the alpha beta of this multi-factor of this single index kind of a model. I need to express for each security the alpha, beta and the epsilon, and I need the market return here. So overall I require 3n plus 1 kind of items. Whereas when I'm going ahead with a multi-factor model, wherein I'm looking at alpha 1 plus beta 1 f1 beta I fi, so wherein I'm looking at alpha I plus beta I1 factor 1, beta I2 factor 2 plus beta I3 factor 3 plus so on plus Ci, which means I require n such kind of alpha i's, I require n such kind of the Ci's and the standard deviations associated with the Ci, and beta I. So for each one, assume that there are L factors that are being considered. So L factors multiplied by n different elements. So I require NL different kinds of data values associated for each of the L factors, and for each of the factors I require a mean value. So which means I require L different number of means, and at the same time there could be interrelation or a kind of a correlation that could be existing between each of the factors, which means I require to find out the covariances between each one of them, which will give me L into L plus 1 by 2 such kind of covariances. So overall the number of data items that I need is L means, L into L plus 1 by covariances, n different values for alpha I, n different values for the standard deviations of Ci, and obviously NL different values for for the coefficients that are associated for each of the factors. So overall it is coming out that I require L into L plus 3 by 2 plus n times L plus 2 kind of a data item in case I am going with a multi-factor kind of a model. In case I am going with a single factor model, I just need 3n plus 1 data items. But when I am going with a multi-factor model where there are L factors that are being considered, then I need this much. So probably in case if L is 1, I can very well check it out for a single factor model. In case L is 1, it is becoming 1 times 1 plus 3, 4 by 2 plus n times L plus 1 plus 2, 2. So it is coming out to 3n plus 2. Yeah, here it's not 3n plus 1 because I require 1 for Yeah, one for the expected return of the market, and one I also require the variance of the market return. So actually I would get 3n plus 2 parameters in case of a single factor model, whereas in case of multi-factor model, if there are L different factors that are being considered, I require L into L plus 3 by 2 plus n times L plus 2 kind of factors, that kind of data elements to properly estimate the parameters quite comfortably. Alright. So this is how we can differentiate between the number of parameters that can be estimated going into a single factor versus the multi-factor models.